In this tutorial we're going to discuss about Biot-Savart law, and this will tell us the source of the magnetic field. And experiments were done, and it showed that, well, the source of the magnetic fields are due to a current. This depends on the magnitude of the current. It depends as well on the distance between the source and the point where we are evaluating, and the geometry of the source. So it's not the same, for instance, a wire or a magnet or whatever, right? The equation that will help us to determine this magnetic field is Biot-Savart equation. So imagine we have this wire with current I, and I will have certain point P where I will evaluate this magnetic field. And in order to do this, I will, for instance, generate or take a small piece of this wire. This will say, for instance, this is a differential of wire. And for instance, this is dl, and the vector dl will point towards the direction of the current. The other vector is going to be, for instance, a vector which is a vector unit vector which points towards the direction in the same direction line as the point that we are going to evaluate, and this is, for instance, the unit vector r. So Biot-Savart will state that the differential of magnetic field is going to be equal to a constant mu0, which is the permeability of free space, over 4p times I times dl in a cross product with r over r squared. Or in other words, the integral form will state that B, the direction, the magnetic field, is going to be equal to mu0, once again being mu0, the permeability of free space, over 4p times the integral of I times dl cross r over r squared. Now, for instance, mu0, which is the permeability of free space, has a value of 4p times 10 to the minus 7 Tesla times meter over ampere. I is the current, dl is the differential of a wire, so in this case we will have to do an integral. We will do that exercise in a further tutorial. And r is, for instance, the distance, the radial distance from the differential towards the point of evaluation. And this r, which has like a hat, will give me the unit vector that goes in the direction of r. So, well, in this sense, we should do an integral and we should do a lot of transformation. We're going to do this for certain very useful geometries. So in this tutorial we discussed Biot-Savart law, which will tell us that the source of the magnetic field is due to a current, and it depends on the current, the distance, and the geometry.